going to do is we're just going to look at the problems that you should have completed in your workbook on page 9. It's numbers 1 through 9, isn't it? Or 1 through 7, or I don't know. But that's what we're going to be looking at. Let's see if we can add anybody to our class. Oh well, I don't think it's going to work. Okay, so let's go ahead and jump in and look at this. You're looking at page 9, numbers 1 through 9. So as we're working through these, I'm going to kind of reteach what I already taught in that very first video. But this stuff comes up over and over again throughout the other videos, so I want to make sure that we understand it and we know what the heck it's talking about. So looking at this function, it asks us to identify the domain, the range, and the codomain. And the thing to remember with codomain, it's probably the most confusing, but the codomain is always all real numbers unless stated otherwise. It will always just be this. You can plug it in. And if it's not this, then it will say what it is, so then you can write whatever it says that it is. So the codomain, it's confusing because it's something that we've never heard about, but it's actually the easiest because it's either one of two things. It's exactly what they tell you, or it's all real numbers and you don't even have to think about it. So identifying the domain. What would my domain be? Do you guys know what the domain is? Do you remember from Algebra 1? The x values. My domain is my x values. So I'm looking for all of the values of x on this function. Is there any value that's not going to show up on this function? No. So we automatically know that it is all real numbers. And we can be fancy about it using our set builder notation, x such that x is an element of the real numbers. This is set builder, or I can use interval notation, which is personally my preference, but I don't care which one you use. I will grade both, either or. It goes from negative infinity all the way up to positive infinity. That just shows me that x could be any of these numbers. And notice I use parentheses and not brackets. Parentheses shows that it doesn't include infinity because infinity is not an exact number that I could include. So what is my range? What are my y values? All real numbers yet again. So once again, we can say this time the y such that y is an element of the real number system. Could be any number out there, or we could use interval notation and say it goes from negative infinity to positive infinity. And then the last part of this problem asked me to identify if it is onto or not. So what does it mean to be onto? Well, in order to be onto, my range and my codomain have to be the same. So if you look at this problem, my range is all real numbers, my codomain is all real numbers. So is this function onto? Yes, it is. It is onto. Okay, looking at our next graph. This one's a little bit different. It is non-linear. There's curves to it. So looking at my domain, once again, I'm just zeroing in on these x values. And imagine with me that if I was to extend this line on down, it just keeps on going further and further and further over. And so does this one. It's not like it's a straight up and down line. It's going out ever so slightly as it goes down. So that tells me that every x value is a possibility because this keeps on going forever to the right and it's going forever to the left. So what would be my domain? All real numbers. I'm just going to use interval notation. Now looking at my range. My range is a little bit different. Am I ever going to have a point up here or here or here? No. Because my graph, the arrows are pointing down. They're not pointing up. So it's never going to go up above that line. So how could we write that to show what our range is? Perfect. It is y such that y is less than or equal to 2. That is our set builder. Or if I use interval notation, I'm saying, okay, it's going on forever down towards negative infinity, and it comes up to 2, and it could be 2, so I have to put a bracket to show that it could be 2. All right, and my codomain, it doesn't state anything different, so what is my codomain? All real numbers. Okay. So is my function on 2? No, why not? Perfect. Not on 2 because the range and codomain are different. Perfect. All right, looking at number 3. What is my domain? All real numbers. X such that X is an element of the real number system. And once again, it's a little bit tricky because it looks like it's just going straight up, but we know that it's going ever so slightly out as it goes up. And what is my range? Perfect. Y such that y is greater than or equal to 0 because it starts here at 0 and goes up forever. And my codomain is all real numbers. Since these are different, it is not on 2. Pretty simple now that it's explained maybe a little more in detail. Maybe it was simple before, I don't know. Does this make more sense, you think? Yeah. There's something about
it just makes a difference.
It does. It really does. Like interacting,
Yeah.
being able to ask questions and talk. I don't know why it makes a difference, but it does. All right, so number 4, looking at our table. We're trying to define the domain, the range, and this time we're going to say if it's 1-to-1, 1-to, both, or neither. So we have to know what 1-to-1 means. And I think 1-to-1 sometimes gets a little bit confusing because you remember back to Algebra 1, in order to determine if something was a function, we looked at the x values. If x was repeated and it was paired with 2 different y's, then it was not a function. It's very similar with 1-to-1, but this time we're looking at the y values. If we have 2 y values paired with 2 different x values, then it's not 1-to-1. Does that make sense? Does that kind of help clear it up a little bit? So my domain is all the values there listed in the week. So my domain is 1, 2, 3, 4, 5, and 6. Read to me my range, please.
10, 15, 22, 15, 40.
Perfect. Now notice when I wrote it out, I only wrote the number 15 once because it's already there. And I always list them in order from least to greatest. So there's my range. Is my function on 2? Well, now we have to think, what is the codomain? All real numbers, because it didn't state otherwise. So is it going to be on 2? No. Is it going to be 1-to-1? Perfect. No, because, so we would just say neither. We wouldn't have to write no. It's neither 1-to-1, neither on, it's not 1-to-1 nor on 2. Because I have the 15 paired with 2 different weeks. All right, so looking at number 5, the table shows the load temperatures in degrees Fahrenheit. What's my domain? 1-7. What's my range?
Let me tell you again in order from least to greatest.
Yes, please.
41 43, 44, 46, 52, 53, 56.
Perfect. Is it, what's my codomain? It doesn't ask us that, but I'm gonna go ahead and write it anyway. All real numbers because it didn't state otherwise. So is it 1 to 1? Or is it on, let's do on 2 first. Is it on 2? No, these are different. So it is not on 2. Is it 1 to 1? Yes, because each y value is only listed once. All right, and if I were you and I was doing number 6, I would not take the time to write all of those out. I would write up above the mean, distance, domain. And then I would write up above the orbital, period, range. So looking at that, is it 1 to 1? Yes. Is it on 2? No. All right, and then I'm going to skip to number 7. Looking at number 7, it is a horizontal line. Any horizontal line will never be 1 to 1 because what is the y value always going to be? It's the same. So y is a constant. And in this case, what is that constant? I think it's 3, isn't it?
Yeah.
Y is a constant. It's 3. Therefore, it cannot be 1 to 1. Is it on 2? What would my range be? Range is 3. So it's y such that y is equal to 3. Or if we're looking at interval notation, it's 3. Oops, I don't know why I put a comma there, but 3. So it's not going to be 1 to 1 because or on 2 because my codomain does not match my range. Okay, looking at number 8, parabolas are never ever going to be 1 to 1 because think about the parabola. It's a mirror image. There's that perfect line of symmetry. So you're going to have the same y value on either side paired with 2 different x's. However, my range, we got to think about it. Is it all real numbers? Or is it, my x values are all real numbers, but is my range all real numbers? No. It's all real numbers greater than or equal to 0. So this one is neither. And then number 9 is both. All right, so before I turn you loose on your assignment that I have for you to do today, I want to discuss discrete and continuous. And we'll give you some examples of things that are discrete. You might remember this from Algebra 1, because we do talk about it. Continuous. In Algebra 1, students always try to argue with me when I start giving them examples. I say discrete is like going to the store and buying a gallon of milk. You're not going to buy a part of a gallon of milk, especially right now during Corona. You're not going to take home a gallon of milk that looks like someone's tampered with it, right? Or touched it or drank out of it. Like, how disgusting. Who would do that anyway, regardless of coronavirus? So discrete is things that are going to be points, exact things. I can only buy gallons of milk as a whole gallon of milk. I can't buy part of a gallon of milk. So gallon of milk is an example of discrete. Rolling a dice. If I roll a dice, I can't have 1.3. My dice isn't going to land on 1.3. What are going to be my possible outcomes? 1 through 6. Perfect. We can only get 1, 2, 3, 4, 5, or 6. I'm not going to roll it half the time either. I'm either going to roll it 2 times, I'm going to roll it 3 times, I'm going to roll it no times, but I can't roll it negative times. I can't roll it fractions of a time. I roll the dice and I get these numbers as outcomes. So rolling a dice is an example of discrete. Buying gallons of milk at the store is an example of discrete. What could you think of that you would buy, that you could buy fractional amounts of?
Pie, like you cut it in smaller pieces, you can buy less than a whole pie.
That is true. But even then, could you buy a finite small piece? Could you buy like a crumb? I mean, technically, I guess you could, but there's a better example. I see where you're going with it, but that's still kind of discrete because you're buying a fourth of the pie, an eighth of the pie, up to a whole pie. You couldn't buy more than the number of pies that are there. Does that make sense? Think about something that you purchase that's a liquid, that's gonna come out at a constant rate. Maybe you don't purchase it yet, maybe you're not 16. Gas. What were you thinking? You're looking at me like, what are you talking about, Miss Blevins? Putting gas in your gas tank, it comes out of the constant.
You're like 16, I was like, wait, what the hell? Oh, boy.
So purchasing gas for your car. That's funny. Purchasing gas. If I squeeze the handle, I can put in little droplets of gas. I could put in a whole gallon. I could put in a part of a gallon. Does that make sense? So this is a continuous. When I graph it, there's no breaks in it, in the graph. Discrete is going to have random places. It might be a step function that looks something like this. At this point, it's continuous, but because this is included in my graph, it is a discrete function. It's not continuous. So discrete are, I don't really want to say whole numbers because it could be fractions. It could be half a pie or a fourth of a pie, but it's not connected. You're buying this much pie for this price. You're buying this many gallons of milk for this amount of money. You're rolling the dice this number of times and getting this outcome. Continuous is you can get any amount you want. You don't just go buy a gallon of gas. You squeeze it and you stop it when your car is full. And however much goes in is how much you pay for it. Does that make sense? Okay, so what I would like for you to do for the remainder of the period is on page 10 and 11 in your student workbooks, we're going to work out the odd problems. And once again, I realize that you guys have a ton of things that you are responsible for right now. You have your Chromebooks, you've got to make sure you got a mask, you got to make sure you're going around the hallway in the correct direction. Now we're using our lockers more. I get it. There is a lot that we're processing. So if you forget your book at home, I will have everything that you need, and I will try to do this all year long, posted on Google Classroom. So if you go to Google Classroom and you click on today's assignment, lesson 1-1, numbers 10 through 11 in your student workbook, complete and submit. I posted it and I deleted out the problems that you didn't have to do. However, you're probably going to want to work it in your workbook or on a separate piece of paper. And then when you're done, I don't know if you did this on a previous assignment. I won't pull it up since I'm sharing my screen. But if you look back at the problems that we just did together in class, those were assigned on Friday. When you click on that, make sure that you view the assignment and then upload it and then put mark as done. It will give you the option to take it. And I would do this on my phone. I know that school policy is not to have cell phones out at school. So if you need help doing it, go bring your phone to class the next time and I'll show you how to do it. And then from then on you can do it at home. But you're just taking a picture and you're uploading it. It's a whole lot easier than trying to take a picture of your Chromebook, like holding it and hitting the camera and then trying to find the file in your Chromebook. I think it's a lot easier to use your phone. So anyway, you're probably the two that submitted it or no, wait, I've got 7 people that turned it in. Never mind, only 2 that haven't. It's you 2 that didn't do it, isn't it? So anyway, that's that. Any questions for me? Okay, and if you notice, I don't know if you want to work ahead, if you don't like to work ahead, but if you know you've got a game next week or something, and you're worried about keeping up with everything, of course, you have the days at home, so you're probably not, but I'm trying to keep going ahead a little bit down here, and then I will post that up to the top when we get there. But I've already got the first 2 lessons done, I have 2 more to do. So, this is a lot for me to try to keep up with Jacqueline. Trying to keep track of everything in class and out of class.
On 10 and 11.
Yes. I'll stop the recording now. Stop recording.